In part one of this little mini series, we started down the rabbit hole of outside air volume control, or CO2 control, indoor air quality control, demand control, ventilation, what do you want to call it. And in that first part, I really wanted to start with the most simple AHU that we have. One outside air damper, one return damper, one exhaust or spill damper, supply and return fans, and VAV boxes. No separate minimum outside air damper, and no volume control, the most basic AHU, because we have hundreds of thousands of those AHUs. And in that video, I hope I convinced you, or at least got you thinking about the idea that we are either bringing in way too much outside air and wasting energy heating and cooling it, or more likely we're not bringing in enough outside air. It's way below the minimum amount, the standard, in which case we have really poor indoor air quality in the zone. Now, a lot of people in LinkedIn and YouTube, some people commented that, well, we need to have outside air volume measurement. And that is sort of correct. You know, if we put a flow grid on the outside air and we have the outside air damper modulate to maintain the set point, say 1,000 liters per second, that is absolutely going to help. It's necessary as part of a completely working solution, but it doesn't work all of the time. I actually don't think that it works a lot of the time. It doesn't actually work. So in today's video, I wanted to sort of unpack that a bit more and discuss a few scenarios with you why simply providing outside air flow measurement does not solve all your problems. Yes, it's a piece of the puzzle, but on its own, it's not enough to have a completely working system on particular AHUs. Let's do a quick 1-minute recap from part one, because it was before the end of year holidays. I'm sure we've all forgotten about that video, and I want us to be on the same page moving forward in this part two. So just 1 minute, super quick, just bear with me. In part one, we discussed generally the idea that when we have the return air fan tracking the supply air fan by a fixed difference, say 10%, so it has a supply air fan, the return air fan, it's a 10% difference. And then as the supply fan slows down, the return fan slows down. They just do this. We discussed that. That's what we always do. So as the supply fan is slowing down and we're sucking less outside air through, obviously the outside air is also reducing. It's all sort of proportional. Not really proportional, but it does that. So I was saying, well, we need to have better return air fan tracking. So while coordinating with the mechanical commissioning technician, as we override the supply air fan from 100, 90, 80, 70, 60, 50, 40, 30, we get the return fan to wherever it needs to be to hold the outside air constant, say 1,000 liters per second. So as the supply fan is slowing down, the return fan is doing something different, whatever it needs to be. That was the principle of the part one video. As the supply fan goes from design to minimum, the return air fan tracks to a different amount, not 10%, it can change, and that will hold the outside air at 1,000 liters per second. Now, in the YouTube, LinkedIn comments, people were correctly saying, well, Bryce, just put outside air volume measurement there, which is great. Just keep in mind that in part one, that million AHUs, they don't have outside air volume. We aren't going to go install outside air volume flow grids on 1 million air handling units around the world. We could just fix up the return air fan tracking. But let's discuss this for a second. So if we now have an AHU and we put outside air volume measurement on there, what happens is it solves the problem, sort of. As the supply fan is slowing down with the incorrect return air fan tracking, as the supply air fan slows down, it sucks less air through the outside air dampers. And if you're looking at the BMS, you will see on the graphics, you'll see the supply air fan slowing down, and you'll see the outside air volume starting to drop from 1,000 liters per second. It starts dropping, 900, 800. And then our PID loop on the outside air damper opens more to hold the 1,000 liters per second set point. So if you sat there and you watch the supply fan drop, you would see the outside damper opening. And that is correct. It then holds the 1000 liters per second outside air. The problem is that in my experience of testing this many times during witnessing on new construction projects is that a lot of the time, this is what happens. The supply fan slows down, 100, 90, 80, 70. Outside damper opens, and they do this. And eventually you get to a point where the supply fan is slowed down to say 50%, and the outside damper is now at 100%, holding the 1000 liters per second outside air volume at set point. And then as the supply fan drops, 49, 48, 50, 40 lower, then the outside damper is already fully open. So the outside volume starts to drop. That's what happens. I've seen that many times because during construction, I do test this with everybody there. The BMS company's there. We're doing a full-on test. Mechanical is there. We've got the mechanical commissioning technicians out there checking things. We do this and it fails many times. Maybe most of the time this sort of happens. Now, let me just pause for a second because I know a lot of you are saying, Bryce, I sort of hear what you're saying, but I've seen this work many times. And there is a situation where it does work. Let me explain that to you. Let me have a break first. Let me first talk you through the scenario where it works, and then I will talk you through the scenario where it does not always work. So if you have an air handler unit that does not have a separate minimum outside air damper, you just have the big economy damper, the big outside air damper, the big free cooling damper, and the returnless spill. This is what happens. As the supply air fan is slowing down and the return air fan is tracking to the incorrect amount, the 10%, as the supply fan slows down, the outside air volume reduces. And there's a PID loop and the outside air damper, the main economy damper, that damper opens to bring up the volume to the design, 1000 liters per second. As the supply fan slows down, the measured outside air volume decreases, reduces, the outside damper opens. What does the return damper do? The return damper closes because the return damper is inversely controlled with the signal of the outside air damper. That was a bit confusing. With economy cycle for free cooling, as we open the outside air damper for free cooling, we close the return damper. We all know that. So when you do not have a separate outside air damper and you're using the big economy damper, we actually have the return damper assisting in the outside air volume control. And in my mind, as we're closing the return damper, which means that the supply fan is now sucking less air through the return and it's sucking more air through the outside air, in my mind, that closing return damper and reducing the volume of air through the return, through the mixed in the return, it's a little bit the same as the return air fan slowing down more and bringing less return through there. So that might not be actually correct mechanically, but from a controls point of view, in my mind, closing the return damper, it's a bit like slowing the return fan down. There's less air coming around, so the supply fan is drawing more air through the outside air. That's when this thing works. It works when you don't have a separate minimum outside damper. But the thing I want you just to think about for a second here is that it sort of works because we're closing the return, we're reducing the return, which is like part one video. Part one video says we control the outside air, we help it by slowing the return fan down more than the 10% difference with the supply fan. So that's when you are seeing this probably work. When it does not always work is when you have a separate minimum outside air damper. So I think in the last, say, 10 to 15 years, as you've been having more complex control around CO2 control, demand control, ventilation, mechanical has been kind enough to give us a separate minimum outside air damper to control that. So we need a smaller flow grid. We'll get better control there. It's a smaller damper. It's not great, I don't think, having massive airflow station across a massive outside air damper. It's another discussion for another time. But with a separate minimum outside air damper, what we do is we put the flow grid there. As the supply fan slows down, the outside air volume decreases, the PID loop opens, the minimum outside air damper. The return is not connected in that situation. I would say that 99% of the time, towards 100% of the time, BMS engineers are not coupling or sequencing the minimum outside air damper with the return damper. They're not doing that. And that's why it doesn't always work. You know, sometimes it does work, depending on the mechanical arrangement and the VAVs and the duct work and blah, 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 and the return air fan tracking. Maybe you've got that, not too bad. You know, on the VAVs, there's Vmax on all the VAVs and there's V minimum on all the VAVs. Whatever that difference is, it's a piece of the puzzle, right? The lower the V minimum is, the more that supply fan is going to slow down. So you will have jobs with a separate minimum outside air damper with volume sensing, and you won't do anything with the return damper. It might work. Like, it might work. It might get you by most of the time. But there will be situations where it doesn't work. I've seen it so many times. I'm not guessing. I'm so many times tested this. Yep, that doesn't work. Go away and come back. They've either got to redo the return air fan tracking, which I think we should do. I think the return air fan should be doing a lot of the main core work to get the outside air right. And then you could have outside air volume measurement, just tweaking it, trimming it. I don't think it should do all the work. I'm just going through the video edit a few days later, and I've just realized a massive reason why you might be seeing this work and why I see it not working. So I'm about to explain something. I don't know how I didn't think of this on the previously, how in Australia having a separate minimum outside air damper doesn't really work, where maybe in North America or the UK maybe it does work. So in Australia, on every single air handling unit, not just premium buildings, every single air handler that has VAV boxes, we dynamically reset the AHU supply air pressure set point up and down. I don't think that that's been done everywhere in the world. So if you have an air handler unit where you live and you have a fixed 200 Pascal AHU static pressure set point, 200 pascals, fixed set point, as the VAVs close off, the pressure goes up, your supply fan slows down, you hold the 200. Supply fan slows down, supply fan slows down. You're holding this fixed 200 pascals, which is the design set point. We don't do that in Australia. We drop that down. So on all of our projects, all of them, we have, you know, AHU supply pressure max set point, which is the design, air balanced, and a minimum set point, 200 and 100. And, you know, on the hottest day of the year, when the VAVs are all at Vmax and all the chillers are running, all the pumps are running, it's a hot day, we're in full cooling, then the BMS will reset up that pressure set point back up to the 200 pascals. We need full pressure and full volume. But on any day that's not 35 outside and the VAVs are not all at Vmax, we start dropping that down, like down to 100. And it's gotten to the point in Australia where we've been transitioning away from comfort control and focusing so hard on energy efficiency that I'm okay with 2 or 3 VAVs being starved of air. Damper's fully open, we're not getting enough air. As long as the temperature is still within the lease conditions, 21 and 24, we don't have temperature complaints. I'm okay with that. A lot of traditionalists are not going to agree with it, that's fine. So, if you're in North America or somewhere like that, and you're saying, Bryce, I see this work all the time. Well, maybe it's because your supply fan doesn't slow down as much as our supply fans slow down. You know, say for example, your VAVs is winter, all your VAVs are to V minimum, and your supply fan is slowed down to 50% to hold the 200 Pascal, the design value, 50%. We're going to reset that down a bit, and our fans are going to go down from 50 lower, 40, maybe 30. So on our AHUs, because we're running the supply and return fans so slowly, slower than you are, we are not getting enough outside air in, or we need to either close the return damper to suck more air in, or we have to have the correct return air fan tracking so that the return fan is slowing down dramatically more than the supply fan is. And in extreme conditions, and this might be another video, we have to turn the return fan off completely. I don't want to get into that right now. I'm just in the middle of this. I've got things to do. Back to the video. All right, that is the main part of the video. So what is your call to action? What do I want you to do? Because believe it or not, I don't record these videos for fun. I record these videos in the hope that people will get a few ideas for something and go make a few changes and make things better. And I'm actually feeling it's even less fun today. I'm feeling a bit anxious today because today is probably the second time in 3 years that I'm recording a video during the working day. Today's Monday morning. I couldn't do it yesterday. I'm doing it today. And I was sitting here thinking, Bryce, you should be working on revenue generating projects, not free stuff like this. So yeah, I'm not doing this for fun. This is what I want you to do. Obviously, it is impractical or stupid for me to say to you, please go and fix 1 million AHUs that have the complete wrong outside air control. I'll see you in 10 years. It's ridiculous, right? We have 20 years of wrong control strategies to fix. But this is what I want you to do. There's 2 things I want you to do. The first is, I want you to realize that outside air volume control is very complicated. It is not the matter of opening a damper. It's very complicated. That's the first thing I want you to realize. I want to just get your attention. This thing is complicated. It's not a simple PID loop and a damper. It's even worse because, what about those AHUs that don't have outside air volume control? We have to have the return air fan tracking right. We can't do the wrong return air fan tracking. So there's like a million things to deal with here. So the first thing is, take outside air control seriously. I want to swear, right? It's very complicated. The second thing I want you to do is, if you're a BMS engineer working in new construction, start playing with this during your commissioning phase. Set all the VAVs to Vmax, let the AHU settle down, set all the VAVs to Vmin, and sit back and watch the AHU transition across. Watch all the VAV dampers close off, system pressure goes up, supply fan slows down, return fan slows down. What's going on with the outside air? Have a look at it. If you don't have outside air volume measurement, what you do is this: set the VAVs to Vmax, walk around the AHU, stand by the outside air damper, and feel the air flowing over your face. Get a piece of paper, flap it in the wind, feel the volume of air across your face. Set the VH from Vmax to Vmin and walk back around again. Oh my gosh, the air is reducing. I'm telling you now, I have seen situations in existing buildings where I've been engaged as a consultant to troubleshoot a problem. I go there's no air coming in the outside air. Nothing. Dams are open, there's air not coming through there. Slow the return fan down, you start to feel the air coming in. Okay, so if you're a new construction person, play with this. If you're a service technician, start playing with this. That's all I want you to do. 2 things. 1, this is difficult, take it seriously. 2, start playing with it and getting your head around how this works. There's a lot happening, changing in my business this year. See in the YouTube description below for what's going on. A lot of training, coaching, supporting BMS companies with consulting services, blah, blah, blah. Very exciting. Can't wait. Go check it out. Thank you for watching, and I might even do a part 3 to this. I've got an idea for part 3. Thank you for watching, and I will see you in the next one.